Hello students, welcome back. How are you? I hope you're all fine, healthy, wealthy and fit. So students, in the previous section we had talked about what the probability is, what is the certainty or uncertainty of having some event or not having the event. So basically what the probability is, what is the basic use, why we are studying probability in mathematics. The second thing was that, and third we had a brief idea about the experimental approach of probability. So we were reading this as probability and experimental approach. So this we are going to talk about in today's lecture, and we'll perform some fun activities. So are you ready for these fun activities, students? Right. So talking about the previous class, in the previous classes what we have done, in the previous classes we had performed some activities, and in these activities we find out the probability in some experimental ways. Okay, right. So in earlier classes we have had a glimpse of probability when we performed experiments like tossing a coin or throwing of a dice, right, etc., and observed their outcomes. We observed their outcomes, right? And now we will be learning to measure the chances of occurrence of a particular outcome. These words are important. Outcome in an experiment. What is outcome? If I'm going to talk about tossing a coin. So if I'm going to toss a coin, like you usually do with your with what you call it, your friend or your sibling, right? So you'll be tossing a coin, and the outcome of it can be two. Like it may be a head or it may be a tail. So these two are what? Outcomes. How many outcomes it will be having? Outcomes. What is coming out? A head or a tail. So this head is one outcome. This tail is one outcome. Okay. Now, so we are going to talk about it. Now what activity we are having? The first activity we are having, that we have to take a coin, toss it 10 times. How many times we are going to toss it? 10 times. Right? Now, then you have to note down the number of times a head and a tail comes up. Record your observation. You have to record your observation in the form of the following table. So you are having a table here. The table is important, so you are going to record it, and based on this table you are going to calculate something, and that something is going to be your probability. So take it step by step. Okay, now here's the table. Number of times coin is tossed, right? Then the second thing is number of times heads come up. Okay, number of times tails comes up. So you had a coin. Now just take a coin and do your own little experiment, and tell me the results in a comment. Right. So here we are having the first trial, we got a head. In the second trial I got a tail. Then in the third trial you got a head, and the fourth trial got a head again, and the fifth trial tail, and the sixth trial tail, in the seventh trial head, in the eighth trial head, in the ninth trial head, and the 10th trial, let's suppose you got a tail. Okay, so now number of times head comes up. Okay, so we are going to count the heads here. Now 1, 2, 3, 4, 5 and 6. We got 6 times heads. Now talking about number of times, there are basically two outcomes. Either it will be head or it will be tail. So if it's not head, it will be definitely tail. That will be going to be 4. But just for like the procedure, we are going to count it 2. So tail 1, 2, 3, 4. All covered. So that means 4 times. Number of times are 4 that we got the tail. Head 6 times, tail 4 times. Okay, so we can write it here. Head 6 times, tail 4 times. Okay, now Now here, write down the values of the following fractions. What are the fractions? First, in the first one, we are getting number of times a head comes up. Number of times the head comes up. Head comes up how many times? 6 times. Upon total number of times the coin is tossed. Now look in your notebook, in your record book where you are recording, you flip the coin, you toss the coin, not flip the coin, but toss the coin 10 times. Okay, so 10 good times it is, so here will be 10. If I'll talk about the number of times tail comes up, so it's going to be 4 only and 1 time. So if I'll be solving the value here, it is going to be 0.6 here, and it's going to be 0.4. So for head, I got a number of 0.6 and for tail, I got a number of 0.4. These numbers are equal or not? No, these numbers are not equal. There is a fine difference of 0.2. Right? Okay. Now what? What is next? Now, toss the coin 20 times. This time you're going to toss it 20 and the same way record your observation as above. Again, find the values of the fractions given above for the collection of observation. What you had done this time, you just increased the number of trials. Number of trials, that means how many times you are performing the activity. You were performing the activity 10 times. The first activity, in the second activity, you just doubled it and it was 20 times. So you had 20 trials, and in these 20 trials, it will be either head or tail, right? Either head or tail, right? And you again record it. Now repeat the same experiment by increasing the number of tosses and record the number of head and tail, then find the values of the corresponding fractions. What you are going to do, increasing the number and again finding, tossing it, again having the record of it, but just you are going to increase the number. In the first one you got head, for head you got 0.6 and for tail you got 0.4. Right? Am I right or wrong? As you will increase the number, that is, if you are increasing number to 20 times, you will see that it will be going something like 0.53 maybe, and it will be going like 0.45 maybe. Okay, I'm not sure about it, but definitely if you are increasing the number, then it was expected that this value is going somewhere near to 0.5. Okay, repeating the same experiment. Now you can ask me that, ma'am, we do not have that kind of time and that type of kind of energy to be concentrated in only one activity. How many times we can perform it? Okay, so what you can do, you can just call your friend, and you're like a very good friend that can honestly tell, and first she'll honestly do the thing, do the activity, and will definitely convey the correct results without any mistakes in it. So after you'll be having 3 or 4 friends of yours, and okay, you are performing 100 times, he is performing 100 times, your friend maybe Kavita. Okay, so Kavita was there in the previous lecture also, so I just picked the name. So Kavita is also performing this activity, and one of your friend, let's suppose Yash, is performing the same activity, and these 4 guys are handing you over the result. These 4 guys and plus you, the 500 results you're going to have, and you just have to say that, like you're just going to add that if the Kavita is getting some number, and Kavita is getting some number, Yash is getting some number, you is getting some number, you, okay, and let's suppose one is me, so me is getting some number, okay, and let's suppose Ayushi is getting some number, okay, and let's suppose Himanshu is getting some number, 1, 2, 3, 4, 5, okay, 5 is done. So you are getting some 5 results, and you are going to sum it up and divide it. These are the number of heads only, okay, so you are going to divide it by how many times? 500. So this summation upon 500 will be going to be the answer of the fraction of probability of head only. Okay, then you will be asking same from me, from the Ayushi, from the Kavita, and from Yash. Okay, and your own observations will be adding them up for the tail. how many times tail comes up in that experiment. Okay, and then you'll be dividing it with number of trials. How many are that? 500 number of complete trial, 100, 100, 100 and 100 and 100. Okay, so 500. So 500 trials. So you will be getting the fractions, some fractions you will be getting here. Now what you will observe that if you'll be having the number of tosses gets larger, the value of the fraction comes closer to 0.5. Right? To record what happens in more and more tosses, the following group activity can also be performed, and I have told you about the group activity. So from coming from 10, then going to 20, and then going to something, the number like 500, will be getting definitely number very close to 0.5. Okay, very close to 0.5. So can it be better said that if you are going to have a very large number of trials, then the result will be surely very 0.5. Okay. Next. Now, 2 coins. This is a different one. Is now 2 coins. Toss 2 coins simultaneously 10 times and record your observation in the form of a table as shown below. Now, what is the table here? Number of times the 2 coins are tossed. Then number of times no head comes up. Number of times head comes up, and number of times 2 head comes up. What is going to be done? You are having 2 coins. Okay, this is coin number C1, this is coin number C2. C1 and C2 are 2 coins, right? C1 and C2 are 2 coins you are having. Okay. Now what's happening? If you are going to toss it, what can be the outcomes of it? Maybe the C1 is head and C2 is also head. Okay. Now the second outcome may be that C1 is this is about C1 and this is about C2. Okay, so C1 is head and C2 is tail. The third outcome may be that C1 is tail, then C2 is head. And the fourth outcome can be that both are tail. There are 4 outcomes. Okay. Now, we are concerned only about the head part here. So, definitely this will be vanished. We are having both tails here. In the first part, number of times no head shows up. No. Here it's also here. Right. We are having this fourth one also. What we are having, one time head. In the both conditions, the condition number 2nd and 3rd, in both the conditions, the chances are we are having one head or one tail. Right. So the first condition, number of times no head comes up. There is a chance of getting both the coins to be tossed simultaneously and getting both as the tail. Okay. So these these times, then you will be getting both tail. You will be counting it here. Okay. Now number of times one head comes up. Number of times. What are the situation? Is C1 get heads and C2 gets tail, or C1 gets tail and C2 get heads? Okay, C2 head shows up in the C2 coin. In these both two cases, you will be writing the numbers here in this section. Then the third, number of times 2 heads come. The first one is also head, the second one is also head. In this time, here in this particular time, you'll be recording it here in this part. And we are going to use tally in that also. I will be talking about it later. But now you are very confirmed about this activity. What is that? Okay. Now student, listen to me very carefully. When you'll be having some 10 experiment, there might be a fraction, the fraction that you have calculated. How you'll be calculating it? The number of times no heads come up. Number of times no head comes up upon total number of total number, not toys, coins, total number of coins, total number of tossing. Total number of tossing is definitely going to be 10 in the first activity. Okay, so you are going to toss it 10 times and you are going to write these things like, okay, maybe it's 2 times here and you'll be getting this 5 times, and you are getting it 3 times. So you'll be having a total number of 10 from this table. So 2 times no head shows up, 5 times 1 head comes up, and 3 times 2 heads comes up. Okay, again you will be doing the same thing. You will be increasing number of trials, and again you will be performing the group activity also. And by that performing the group activity, you are going to increase that number of trials to very much extent, right? Okay. So this is how you'll be writing the fractions. So for the first number of times no head shows up, I've told it to be 2, that will be 2 by 10. Here it will be 5 by 10. Here it will be 3 by 10. Just read it carefully so that you will be known. I have just assumed numbers here. You may actually toss the coin and get the numbers here in the tabular form. Right, now number of times no heads come up, 2 times you got no heads by 10, that means both the 10. Then number of times 1 heads come up, that was 5, upon total number of times 2 coins were tossed, that was 10. So that will be simple 0.5. Okay, something like that. And number of times 2 heads comes up, total number of times upon total number of times 2 coins are tossed, 3 by 10.3. Here you are getting 0.2. Understood? Okay. Now, what will be finding? The more the number of tosses, the closer are the values of the A, B and C. 0.25, 0.5 and 0.25. This is for 2 heads. This is for, no, not 2 heads. This were for no heads. Okay, this were for the second one for 1 head, and the third one for 2 heads. So as you will be increasing the number and again you are increasing the number, you will get to know that the no heads probability will be going to be 0.25. Here it will be going to be 1 head, and here 0.5 for 1 head and 0.25 again for 2 heads. This is going to be the thing. Now we are here approached with the empirical probability PE of an event E happening is given by. What is the formula? The empirical formula. Empirical formula, that means the formula which is derived with the help of experiments. So now with these experiments, what we are going to have? The probability of that event. Probability of an event E. That is going to be PE, probability of happening the event E. What is event? If I am talking about getting a head, what is the probability of getting a head? So getting a head is an event. Now I may have number of trials equals to 20. In 20 trials I got, let's suppose, what we are talking about, getting a head. 1 head. Okay, so only 1 head I'll be having from the 20, I'll be having 16 times. Let's suppose I'll be getting 1 head. Okay, in that case I'll be having here number 16 and here I'll be getting the number 20. Okay, that is going to be 0.8. Right? Okay. So this will be the probability of having an event. Now, how the examiner will ask you questions from that? Okay, how is going to be examiner respond to all this? He may give you some data, some tossing data, that if you are tossing a coin, then you are getting head in the first chance, tail in the second chance, third head in the third chance, and tail in the fourth chance, and similarly he can give it to you. Then you can do it by the tally, or else what he can do, he can just tell you that okay, this number of times you get head, these number of times you get tail. Now you are going to find the probability of getting a head. Then what you have to do, just divide the number of, even what you are going to do, you are going to write the number of heads, number of events in that which coming head, that means like a head, okay, 10 times total number of events were 20, then you will be getting 10 plus 10 by 20, and you will be getting a 0.5, okay, as your answer. So this is going to be the method, and that will be more clear, more easy for you students when you will be doing the questions of it. Now, is it clear to you from here till there? So session number 2 is, I guess, so much more clear to you, and what we are going to study next in our today's next lecture. Okay, so we are going to do some examples, and this is the example we will be talking about in our next session. In the next session, we are going to talk about this particular numerical. So just have a look at that and try to solve it by all your own. After solving it, try to match the answer in the next session. Okay, I'm going to do it for you, but as far as my opinion is concerned, student, you should do it by your own. Okay, then we'll have that answer, if you have the matching answer or not. Okay, so with that note, I'm finishing today's lecture. In next lecture, we are going to do some interesting and good questions, and this is a very short and sweet chapter, and this is going to be very scoring for you, because it's not only important in the 9th but also important in 10th and 11th and 12th and so on. So just have an eye on that. Okay, take good care of yourself, students. Bye bye.